The Sun is the center of and the largest object in the solar system. Our planet Earth and all the other planets in our solar system revolve around the Sun. Scientists have estimated the Sun to be about 4.6 billion years old, and it still has a remaining lifespan of about 5 billion years. 109 Earths would be required to fit across the Sun's disk, and over 1.3 million Earths could fit inside it. However, the Sun, which is the nearest star to us, is not as solid as our planet. It is made mostly of gaseous materials, just like any other stars. The center or core of the Sun's interior is very, very hot and has a temperature of more than 15 million degrees Celsius. A process called nuclear fusion takes place there. Hydrogen is being fused to form helium. The energy created by this process radiates up to the visible boundary of the Sun and then off into space. It radiates into space in the form of heat and light. But there's more. The Sun also gives off many kinds of radiation other than light and heat. It also emits radio waves, ultraviolet rays, and X-rays. Also, in the Sun's interior are two distinct regions: the radiative zone and the convection zone. The energy that is produced in the core passes through the radiative zone. This zone is about 2,500,000 degrees Celsius. Next to the radiative zone is the convection zone, where hot gases undergo intense churning motions. This zone has a temperature of about 1,100,000 degrees Celsius. And just above the Sun's interior is its surface called photosphere. It has a temperature of about 6,000 degrees Celsius. At the photosphere, sunspots or magnetic storms appear as dark areas. Just above the surface of the Sun is its atmosphere called chromosphere. Temperature in this region rises to about 27,000 degrees Celsius. The chromosphere is almost completely transparent. During a solar eclipse, it can be seen visibly as a red glow just around the Sun. Solar flares also occur in this layer. These can directly affect the Earth's ionosphere and radio communications at the Earth. Lastly, there is another atmospheric layer around the Sun called Corona, which has a temperature of about 2,200,000 degrees Celsius. It is very thin, so you could only see it during a solar eclipse. The instant the Sun becomes eclipsed, you will see the corona as the whitish glow around the Sun. Solar winds occur in this layer. It is a continuous stream of charged particles which are released from the Sun and hurled outward into space at a speed of up to 800 kilometers per second. The particles are blown out of the Sun in straight lines, but since the Sun is rotating, they form a spiral path. The coronal mass ejections, or CMEs, also occur here. These are huge bubbles of gas threaded with magnetic field lines ejected from the Sun over the course of several hours. And you know, large geometric storms can cause electrical power outages and damage communication satellites. but they can also produce majestic displays of lights in the northern and southern hemispheres, known as aurora borealis or northern lights and aurora australis or southern lights. Can you now see how powerful the sun is?